Okay, so welcome everyone on your first multi-platform Kotlin project. This presentation is a continuation of my presentation from KotlinConf, where I was talking about the possibilities and challenges in multi-platform Kotlin projects. Today I would like to go into the practice. Today I would like to answer to the question how you can start with making your first multi-platform applications. And since we are in a mobile track in here, I will show it on an Android and iOS example, which I believe right now is the most promising since those words are very close together. And I will finally answer to few demands to present how you can do MVVM and view binding using this approach. So first, who am I? My name is Marcin Moskała. I am a creator of Kotlin Academy, now named KT Academy. I am teaching Kotlin in here and worldwide. In here we are conducting local, open and in-company workshops. And I also wrote a book, Android Development in Kotlin. And currently I am finishing a book, Effective Kotlin. And we are going to start with building our first multi-platform project. If you have any questions or if anything is not clear enough, then put your hand up and I will stop and I will ask you to tell me your question and I will answer to that question. So the easiest step, I believe, is to do that, to make your first multi-platform project, is to start by opening IntelliJ, selecting create new project, and then there you will find a lot of templates, and some of them are already multi-platform templates. So you can see JS and JS client and JVM server. This is multi-platform project where both front-end and back-end are in Kotlin. You can see multi-platform library, one library written mainly in a common module, compiled into 3 platforms, so that can be used on Android, iOS, on Java, Scala, CoffeeScript, on Swift, nearly all known languages right now. And also you can see the option mobile, Android and iOS that we will choose today. So an application where you have common parts between Android part and iOS part. When you click it, you will see the following structure, and in this structure you will see in SRC set of directories: common main, common test, iOS main, iOS test. Main is Android because of how Android plugin is designed, and the common parts, the parts that we are interested right now about, are located in the common main. You can also have some tests in common test. So in this common part you can see some expected classes and expected objects. Expected classes are classes without body because their body will be defined in each platform separately. So those are classes that do not exist at this point. They will be provided when you specify how concrete platform looks like. And you can also see some function, some normal class using those expected elements. And this is amazing. You can see an entry point main. When you run it, you will see that it runs on Android because by default it runs on JVM. But making entry points in common modules is a very useful tool to test how something works, to check something out. So just to let you know, if you want to start your project, you don't need to define it in the platform module. You can start it in a common module to see how something works. In Android, when you open Android part, you will see actual classes. So you can see those are actual bodies for Android that will fill the previous expected classes. And you can see some typical Android elements. You can see main activity. We said some view. Everything here is normal. Who is here? An Android developer. Okay, most of you. So this is a typical Android development, but as you can see, you use the common part. You use part from the common module, so you can see that it uses this common part. So when you started using this play button, if you have in your IntelliJ Android SDK, Android plugin set up, or if you open it in Android Studio, it will work as well. Then you will see Android emulator that displays hello from Android, what was defined in a common module and in a platform part in this object. To open, to specify iOS, you need to open iOS main file. It is because Android is placed in main because of how Android plugin is defined, but iOS specific parts needs to be defined in iOS main. If you would have more platforms, they would have their names. You could have JVM name, JS name, etc., etc. And those files do not contain anything really iOS specific. This is a pure Kotlin code, and those are Kotlin actual classes. Sure, this part is written in Kotlin native, so if you add some native libraries, for instance, Objective-C libraries, you will be able to use them here. In this case, I don't use them, though there is no iOS in here. Why there is no iOS in here? Because we want to write iOS natively. And we write iOS natively in Swift in Xcode. So it's located in a separate module, and this part will only generate Objective-C framework that will be used by our Swift module. So you can open this, it's in a separate file, iOS app, and you can see Xcode project. Just to run it, you need to first create a Gradle wrapper. Maybe it's already fixed when you watch it on YouTube, but at the moment the template is still missing Gradle wrapper, so it's a very short command and it should work fine. And once you have your Gradle wrapper, you will be able to open your project in Xcode, start it using big play button, and see hello from iOS. And this is your first multi-platform application. You can start it, if you have Mac, you can start it and start developing Android and iOS with common part in minutes. So you can go home and play with that. Although the bigger challenge is to make project that is, I mean, this was a very simple project. What we want is a real-life project with shared logic that could be used in our companies, where we could use the same presenters or view models both for Android and iOS, so that we don't need to redefine them and retest them on both platforms. So I would like to show you an example project with shared logic. And I needed some applications, so I decided to reuse application I wrote for myself. This is a morning exercises application. It contains a set of exercises. You can move next or back using arrows. You have some timer, and those are basic functionalities. It also reads you what exercise you should do right now, displays some images. So it's a simple but functional morning workout application. And we are going to implement it step by step together on those slides. So that it's on GitHub in here, workout MPP on my GitHub, but based on those slides, you will nearly be able to do it yourself. So first thing you need to do whenever you create a multi-platform Kotlin application is that you need to define views for Android and iOS. And views needs to be defined separately. This is something we assume that is platform specific. So I mean, it could be using some DSL extracted to a common part, but at the moment we don't have such need, because I mean, maybe it would be nice for some minimal valuable product or some prototype, but for now we concentrate on the real life applications, and in the real life applications we generally treat Android and iOS as a views as a separate thing, since they are very often different and defined differently. So on Android I use constraint layout. Based on this slide you could set the same constraints. I assume this is a topic for another presentation. When you set some defaults, some values, and you start it, you will see static view. It looks good, but nothing is going on over there, so it's just a static view. On iOS, I created very similar view. I did that programmatically. I defined elements using normal views, and then I defined constraints using library called snapkit. To implement logic, we want to implement our logic in the common part. And to make it possible, we need some architecture that would allow that. Architecture that would separate our logic from platform-specific elements. And the first architecture, I believe the simplest architecture that allows that, is called MVP. Who in here knows, or MVP? Okay, who in here used MVP in some projects? Quite a few. So probably, I see people, I very often see in projects like unpure MVP, where presenter is strongly dependent on platform, and I would say a pure MVP presenter business logic should be fully separated from platform. So like platform from the business logic point of view is a detail, and presenter should not be aware of view and of model. It should be aware only on the interfaces. And this is what we need in here. Only then we will be able to easily extract it and reuse it. So MVP defines 3 layers. First one is a view. It defines presentation logic, how application looks like, what an area of interest of our designer, an area of interest of our graphic. This is what we just defined. Then we have presenter, business logic, how our application behaves. This is the most important part of our application. We'll talk about it in a minute. Third element is model. All other elements, everything like databases, network repositories, components, and everything hidden behind an interfaces so that it can be, it's like platform is independent of actual elements, so that we can easily replace database, preferences with database and database with, Firebase or anything else. So how can we define model? First of all, we need to define an interfaces. And in this case, since I don't use network, I don't download exercises from network, all I need is our platform-specific elements that are speaker to speak up what is the next exercise, and timer that we set up, and then it ticks every second, and it notifies us when it's done. So those interfaces should be located in the common module because they depend then, they are common, they are part of our business layer. And in both Android and iOS, we need to provide platform-specific implementations for them. And both of them are very simple because both Android and iOS support both of those elements. So I will just quickly show you how it can look like. Android speaker is just a wrapper over text-to-speech, and its method speak just uses method speak from text-to-speech. iOS speaker is just a wrapper over AV speech synthesizer, and its method speak only stops previous speaking just for if you jump very quickly and speaks the next text. So it's very simple wrappers. The same with other elements. The same you would have if you would use a database, or you could use a library that does that for you. Similar we would have with networks, or you could use a library that already does that for you. For instance, if you use Cater client, you can define network in the common module. You don't need to do it platform specific because this library handles that for you. So this way we defined model. And it's time for the presenter, the hardest part, the most interesting part. In presenter we extract our business logic into elements called presenters. Sometimes we later extract them into use cases, but I simplified it a little bit. So in this presenter, we need some contract. This contract should be better described, but for the sake of simplicity, I defined it in the following way. First of all, contract needs few dependencies. timer and speaker, obviously, so we define them to use them in the presenter. And view. View is an element we use to update how our view looks like. And our view allows us to modify, exposes three methods: setup, workout, displayed, update timer, and hide time. So those are three things that presenter can do with our view. And we also have some methods that should be called in some circumstances. On start should be called when we start an application, when we start using this presenter. On next when someone clicks next button, and on previous when someone clicks previous button. We need some list of exercises. For the sake of simplicity, I just made it a static list. Another thing we need is some states, because if you are looking closely at the application I showed you, there is not just an exercise display. Every exercise starts from a preparation. There is an actual exercise, and the same for every single exercise. And on the end, there is a done state. So out of those exercises, you need to have some states. And there is a very popular pattern of state machine that is represented using sealed classes in Kotlin. So every exercise will have a prepare state, an exercise state. We create that using flat map. And on the end, there is done state. So what is displayed on our view is decided based on the current state. So our presenter needs to hold list of states and needs to hold current state. And we will keep that in the property states and state. And so when we start our presenter, all we need to do is to display the first state. Normally it would be more complex. Normally you would probably download it from the internet, set up the first state, and then display it. But since we have a static list, it's just easier. So we just show first state. We'll talk about ShowState in a moment. For now, on next and on previous. And on next and on previous are really easy. If there is a next state, we set it up and we display it. The same with the previous. If there is a previous state, we set it up and display it. So we just handled on next, on previous, on create. All that is there to show is how ShowState looks like. And in ShowState, I defined ShowState in the following way. So in ShowState, we need to update our view. So first we get what is the title text and what is an image URL. We get that based on the state. This is like a Kotlin pattern matching. So where state is prepare state, we produce string prepare for, and then we take state exercise name text. Notice that we can ask for the exercise because state was smart casted into prepare state. And the same with others. Exercise state produce just exercise name, done state produce done, and similar with image names. And so we use those data to display them on the view. Next, we use them to speak up what is the next exercise. Then we need to set up timer. To set up timer, we use another when. This time, it is there to say how much time do we need to wait. If this is an exercise state, we take the exercise time. If this is a preparation state, we take some constant. If this is done state, then we hide timer, stop timer, and then we return, so we do not set any timer at all, because we don't need to. And finally, we start timer for duration second. Every tick, we update timer on view, and once it's done, it's the same as clicking on next. Okay, and that's it. This is all our presenter. When you start it, you need to use it, but our presenter is well defined. Using it is the simplest part. If you have it working, it's the simplest part. You just need to create it. You can create it lazily, and then you just set up presenter on next, call presenter on next, on previous, and on start when events occur. And you also need your main activity to implement workout view. And workout view has few methods that are used to display title, show timer, and hide timer. Surprisingly similar code you will see when you apply presenter on Swift. It looks nearly exactly the same. You lazily create presenter. You make your controller implement workout view. You call on next, on previous, and on start when the following event occurs. And those methods are even more similar. There are few changes, like there is func instead of fun, and you change types in a different way, but in general, it's nearly the same. And when you apply it, you will have working application. And notice that already majority of this application, I mean all behavior and majority of code is in the common module, so I don't need to re-implement it. You can also write some tests. You write those tests in the common part. On the test you can use some mocking library. Mock is supporting common modules. It's not yet working for Kotlin native, so you can only run it on Android, but hopefully it will be supported in Kotlin native as well. And so you can check, you can use mocks, you can verify, you can use mocking like a human. And that's it. We built our multi-platform project with shared logic. So at this point, I was having I was thinking what to show you next, and the most common elements to show next are common API, network API, and multi-threading using coroutines. But many people also asked me about MVVM and view binding. And since the first two I already showed in the Kotlin Conf application, and if you are interested, you can check it out. Both two are possible. Coroutines are not yet officially supported on iOS, but you can make them work. Though MVVM and view binding is something I haven't yet seen on any presentation about it, so I decided that let's show it. So MVVM, who knows what is MVVM? Yep, that's good. Who used MVVM? Quite a few. Okay, so MVVM is a very similar model to MVP. I would say the evolution of MVP. So there are a few significant differences. First of all, instead of view, I mean we crossed out view. We don't need view anymore. So we get rid of this annoying interface. We don't need our activity to implement anything. So it's already nicer. But we need some way to update our view. And we do that by setting up some properties that are observable. And so we just change those properties, and our view should bind itself to those properties. So whenever we change them, our view should automatically change itself. Also, thanks to this approach, we have new cool name. It's not presenter anymore. It's a view model. So we can say to our friends that we are using MVVM. It's easier to test. We don't need to mock anything. It's easier to model. It's easier to support more platforms, because when you need to add something new, you just create a new property, and if some platforms are not supported that yet, they don't need it. Everything will work fine. So you can add new property, add something into Android, and your iOS friends can start supporting that later. So in general, view models are very promising, and they are very liked on Android, and they are part of Jetpack, so people are waiting for them a lot. So we added this mutable property. What is this mutable property? This is a class I created myself. This is how it looks like. If you know Kotlin, it's crazy simple. It's just a wrapper over a mutable value. that also has a set of listeners that you can set up. So there are two things you can do: get and set. Get gets value, set sets value, and also notifies listeners. And there is a method add listener. Crazy simple method, a crazy simple class. I just defined in a minute. So we also need to change our view uses because view does not exist anymore. So instead of, for instance, view, we need to update our properties. And similar changes needs to be applied for other properties. Actually, we migrate them one-to-one, so concrete view use will be migrated into concrete properties update. And on your activity and controller, you can get rid of your interface, get rid of all those small methods. Instead, you need to set up listeners on all those properties. So you can see title properties, title prop, changes, title view text, etc., etc. The same on iOS, but there is a small problem on iOS, and this problem is already known. I'm not discovering an America in here. It was already described on GitHub, and few weeks ago also described on a article that go viral. That was the first serious critique of Kotlin native. The problem is that Kotlin native does not yet interoperate generics well between Kotlin native and Swift, so that when you use Kotlin native from Swift, you lose generic types, and you can see it in here. This add listener, in this add listener, text should be string, but it is not. This type is lost, so it's any nullable. I had to cast it. This is, I admit, this is not good. I'm really waiting for that to be fixed, and I hope that it will be fixed soon. And I understand why it might be a problem for some companies thinking about multi-platform Kotlin projects. Though, as far as I believe, this is the only serious critique. One more thing I would add from myself is this returning Kotlin unit on function types in Swift. This is something that is happening under the hood in Kotlin, but they need to be returned. So when you use Kotlin types, Kotlin function types from on Swift, you need to return them explicitly. This is annoying. I would prefer to omit that. So my solution was to define the following function. My solution was to define the following extension function on mutable property that solved both those problems for me. And once I used it, my view model setup finally looked good enough for me, so that I still need to set those types in here, but at least it's not like ugly casting, but instead type setting, though it's not fully secure. If I would change it on my Kotlin native part, in my common part, it wouldn't shut with an error. It would crash at and runtime. So I hope that this generic problem will be solved. Though setting up types, setting up listeners looks really good right now. When you play it, Android and iOS, it will work fine. You can also do unit tests. In unit tests, I removed mock because I didn't need it anymore. You don't need to mock view because you don't need this interface. Instead, you can just call some methods and see how your properties looks like at this moment. As I told you, testing view models is significantly easier than testing presenters. And so MVVM checked. The last point, view binding. Who uses view binding? I mean the library for view binding Android. Yep, okay. So there are quite a few of you. I believe you find it very useful. I find it very useful as well. And I wanted to show you that you can use it over there as well. Though first step I wanted to show is that without the library, you can do some middle step using some extension functions, so you can extract common bindings, like in here, bindings between UI label and a string typed property, and make some functions like bind text, bind boolean, etc., or bind to visibility. So those can handle most cases, though the real view binding is when you can, on your layout, define how what property should be filled with what mutable property on your view model, so that Android is not a middleman at all anymore. So how you can achieve that? Of course, you need a library for view binding. There is a Kotlin library for, there is an Android library for view binding, part of Jetpack. We need to add it. This library has few requirements. First of all, our view model needs to have extend some class. And we don't have this class in a common module because common module is independent on Android. So to make it possible, we need to create an expected class. So it will be filled separately in Android and iOS. We also need different thing to be mutable property. So mutable property will be an expected class as well. So then on Android, those two needs to be type aliased into view model from Android library and observable field from Android library. In iOS, we'll leave empty view model and mutable property exactly the same as we had before. We don't need to change anything. And so iOS won't change iOS won't change at all. What will change is Android. In Android, we need to use data binding util to bind those two, so to bind layout and view model. And so when you apply it, you will have your application working again. There is a bad animation in here, but it's solved. It's just an old animation. So view binding is checked. So during this presentation, I showed you that making multi-platform projects with shared parts is easy. You can make your first multi-platform Kotlin project in a minute and start playing with that, start extracting common parts. If you have a library and it's a, let's say, Java library right now, and you want it to be used on native programs or on JavaScript programs, you can just extract nearly everything into common part, write actual classes for JS and native, and have your project, have your library for much wider group of developers. We can extract easily logic into presenters, but logic into presenters and view models. One thing that is challenging is the lack of generics in Kotlin native. They are there, but the interoperability with Swift loses that information because it's compiled into Objective-C framework. We can have MVVM, we can have view binding. And this is basically everything I want to show you. I wanted to give you one more announcement that we are organizing multi-platform hackathon here in Warsaw. The date is not set because my co-organizer is still discussing some things with sponsors. So we have only empty website right now in here. So if you are interested, we'll have some experienced Kotlin developers who will be helping everyone teaching Kotlin, and we will be doing together multi-platform application, hopefully for Android, iOS, and web with backend and common part. If you are interested in other events, here is a mailing. We are conducting workshops. Soon in June, we will have another Kotlin in Android. Oh, sorry, this will be a pure Kotlin workshop, but we have a lot of workshops, so if you need them, you have the website, kt.academy. And that's everything. I will show those slides on Twitter, although they were already shown after JetBrains night, so you can find them already in the history. And that's everything from my side. Thank you.